decimal point lines up. So a common mistake is doing something like this. Yeah, that's no good. Yeah, so off kilter here. So this 3 is 3 units. This 5 is 50, isn't it? It's worth 5/10. So they're not in line. So I line up the decimal point with each other. So I can now add. My answer will have the decimal point here as well. What happens if I have a gap here? I'll put a 0 in, yeah. So that 8 and 0 is more than that 7 and 3. Okay, and then this is adding. So 0 plus 3 is 3. 8 plus 7 is 15. I carry that 1. That's 15/10. So I carry that 1 up here into the units. 3, 2, and a 1 makes a 6. And we have just a 5 here. So that's how we add. Make sure you line up the decimal places. If there's a space free, fill it with a 0. Next one, subtraction. There's a couple of ways to do this one. So we can just do 27 minus 3.58. There's no decimal point here with the 27, so I'm going to put in a decimal point and put 2 zeros and do that. Now some of you might be able to do this a little bit quicker with subtraction. Maybe you could think about, well, 27 minus 3.58, that's pretty close to 27 take away 4, isn't it? 27 take away 4 is 23. And then how far away from 4 is this?
32.
42, I think, away? 42, so it's 0.42 away from 4. Will that mean I can just put in 0.42 here? Yeah. Well, we'll see that that's the answer. That's the answer, yes. So this is the answer. That's one way of doing it. We just found out how far we are away, which is a subtraction. How far you're away from something is a subtraction of distance as well. If you're not sure of that, remember what I did here to start off with is I put in some zeros to fill any decimal places. So I know it's a subtraction, the 0 minus 8, so I need to borrow 1. Now, whatever way you do this subtraction, I do this borrowing 1 from the previous one. You have your own method. I think it's slightly different. But 10 take away 8 gives 2. 10 take away 6 gives 4, so that's working out nicely here. And then 27 take away this 4 now, because you borrowed 1, is 23. So there's 2 methods there, whichever one you'd rather. But remember, if you're doing it this way, fill in the gap with a 0. Multiply. We looked at this also last week. First of all, yeah.
Are you supposed to write that?
Only if you want. Only if you want. So, does it matter which one I multiply by which? No, because 2 times 3 is the same as 3 times 2. They both give 6. That's the commutative property of multiplication. So I'm going to actually multiply by the 38. Because it's easier. So you got 2 digits to multiply by. Isn't that right, Darcy? Yeah. Okay. So I'm multiplying by the 38. I'm going to multiply by the 8 first. 8 times 3 gives 24. 8 times 2 gives 16. Add the 2, 18. 8 times 4, 32. Another one is 33. Now I'm going to multiply by the 30. 30 times 3 is 9. 3 times that is 6. And 3 times that is 12. All right, I'm stopping now. I've totally ignored the decimal place, haven't I?
Yeah.
I've just multiplied 2 numbers here. I've ignored these 3 decimal places. Okay, we'll think about that in a second. Let's just finish the add. 4 plus 0 is 4. 8 plus 9, 17. Carry the 1. 3, 6, and 1. 10. Carry the 1. 6. So I have 16,074. So there's 2 ways I can think about how I can get the decimals back in. The way we looked at last week was how many decimal places are in the question. 1, 2, 3. So that means I must put 1, 2, 3 in the answer. Also common sense, yeah. This is a little bit less than 4. This is a little bit more than 4. So what's 4 times 4? 16. So my answer should be around 16, not 16,000. So the decimal place should go here. but you can just count them. 1, 2, 3. 1, 2, 3 in the answer. 3 spots after the decimal. Division is a little bit more difficult sometimes. Just in general, dividing can be a bit of a challenge. I want to divide 4 into 6.372. What's my answer going to be around? Yeah, about 1.5, yeah. 70? What's 4 into 6? So 6 point something. So yeah, around 1.5 maybe. Okay. Kind of ignoring the decimals again. I'm going to do just the division part. 4 into 6 goes once. Carry the 2, yeah. 4 now into 23. So I'm just doing my long division as normal. 5 times only, with a remainder 3. 37, 4 is 9 times, yeah, a remainder 1. And 4 into 12, 3 times. Okay, but I've once again ignored the decimal place. The decimal place was here. Where is it going to be? It's in line still here. So the decimal place was here. It's still in line here. It won't move left or right. This one, if I did this same method, I'd have to think about moving the decimal place. So we had a trick to making this easier. What was it?
Times it by 10.
Times it by 10, yes. I want this to be a whole number. So if I times that by 10, I get 7. But what must I do to this side as well? Also times it by 10. So I get 423. Now I have no decimal points. Are we sure that this works?
Yes.
Yeah, we went through this on Friday. It definitely works because, very simple example, 4 divided by 2 is 2. If I multiply them both by 10, 40 divided by 20 is still 2. Multiply by 10 again if you want. Many times is 200 fit into 400, 2 times. So by multiplying both numbers, I haven't really changed what the answer will be. And all I want, and this is the answer. So let's do this division. 7 fitting into 423. What happens? Well, we'll see if we need some decimal places. I'll put them in because I have a feeling we might. 7 fits into 4 no times. So I put 0 or just leave it blank. 7 fits into 42 6 times, so the 4 was carried. No remainder, but 7 does not fit into 3. So a remainder 3. 7 into 30. 4 times, remainder 2. 7 into 20. 2 times.